Alright, hi. So I wanted to show some more advanced features of Haasoscope Pro. Um, let's look at what you can do hooking up two of them together and how to use those. So as you can see here, I've got two hooked up together. You can put them on top of each other, you can put them side by side, you can put them however you want. To connect them together, you need a few things. So one thing is for oversampling, you need the oversampling cable. This is going to be any SMA to BNC cable. I sell one on Crowd Supply and Mouser that is 6 inches and kind of fits nicely, and I've tested them and they're high quality. But you could use whatever cable you want. You also need on the back, of course you need them plugged in with USB and everything. You might need some extra 12-volt power if your USB can't supply enough power. Yeah, you need this sync cable. So this is just an Ethernet cable, your usual Ethernet-y cables. I like these 1-foot ones that you can get for like $1 or something. Yeah, these will connect together a few important signals so that we can sync up the two Haasoscopes. There was an update post on Crowd Supply that I did during the campaign, which explained how this worked in a little more detail. But basically it's syncing up the clock signal, so one of them will be the master clock and the other one will be synced to it over this cable. And you also can send triggers back and forth from one board to the other, so that the triggers are synced up and the boards record data from the same events. Okay, so what can we do with these two boards hooked up together? And by the way, you could hook up 3, 4, 5, 6, however many you want like this, just by plugging those sync cables on the back from the out of one to the in of the next, and you just daisy chain them all together. And those sync cables can be long too. You can use a 50-foot Ethernet cable if you want to, and have them like far apart if you felt like it. Okay, so what can we do with these? First of all, you just get more channels. So it's hard to see on the camera always, but you've got a red light here and a green light here, and those are synced up to these two channels here that you can click on, and those are your two channels. You can move them around, and you can do what you like. And you also can go to 2-channel mode, and then you've got 4 channels, because 2 times 2 is 4. And but the most exciting thing probably is that you can do oversampling. So when you click this oversampling button, we've got, you see the lights go over from the left to the right, so now we're using these inputs on the right. That's because we can turn off this aliasing, anti-alias filter for the channels on the right, and that'll give us the highest bandwidth. So once we turn off, we leave that filter off, and we've got our signal going in. It's down here, but then it gets split out and sent over the oversampling cable to the input of the other Haasoscope. Once you're doing that, you can see that you've got the signal duplicated and synced up between the two scopes. Now the signals are still a little bit offset from each other and in voltage, and they're not perfectly synced up in time either, although they're pretty close. So to fix that, we have this handy auto calibration feature. So you just get your signal, maybe a few edges is kind of good and helpful, and then you just go up here, calibration, oversampling calibration, and you'll see what it's doing is basically fitting one signal to the other and adjusting the gain ever so slightly and the offset ever so slightly of one signal so that it matches the other one as best as possible. And it also adjusts the time so that the two signals will have samples that are interleaved with each other. So it's adjusting these values here for the delay and the fine delay, which is an ADC delay, so that these two signals are going to be interleaved with each other. What does that mean? Let me show the markers here to a single event. So the idea here is that you can't see it yet because we're drawing all the samples on the same grid, one after another at the same time from both signals. But really what's happening is, you see this one rises first, and then this one. What's really happening is this one is a little bit ahead of the other. So this sample is really in between these two other samples here. And it'll be like that for every event. Now, what you want to do is then put those two signals together. So what we can do is, go back to running, is we press this interleaved button, and now it'll put those two signals together and move them, 1/2 sample relative to the other one. And now you've got them interleaved and matched up properly in time. Right, so you get a super clean fast edge, and you've doubled your sample rate. Right, so here if we look at the markers again, because it's like a little more, it's 6.2. So starting from here, you count 1, 2, 3, 4, 5, 6. It's a little more than 6 samples per nanosecond. Whereas if it's not interleaved, then you have just 3 samples per nanosecond. Okay, great. So we have our interleaved signal, and now everything kind of works as you might expect for a single channel with double the sample rate. So if we're looking at doing a fit to the rise time here or something like that, that's gonna calculate it using this interleaved signal. The mean, you can move them around together, up and down, and you can change the gain, and it all adjusts both channels at the same time and keeps them interleaved. You can even put on the anti-alias filter if you want. That's kind of cool. So our rise time should go from, well, it was really fast, and now it's like 0.8 nanoseconds. So that's corresponding to about a 800 megahertz anti-alias filter. But if you get rid of that, then our rise time shrinks back down again. Okay, so that's the idea of interleaving. Even like the FFT works, and you'll see the FFT now goes up to 3.2 gigahertz. Yeah, hope you enjoy that. And let me know if you have any questions, as usual.